Assalamualaikum and hi everyone. Welcome to Solid Mechanics and Structures Lab. This video will show you how to run experiment for code subject SKMM2921 or SEMM2921. One of the experiments for the code is deflection of proper cantilever beam. Firstly, look at our lab sheet. Title for this experiment is Deflection of Proper Cantilever Beam. Objective for this experiment is to validate beam deflection formula based on a Macaulay method. Experiment equipment consists of Tecumen general beam machine. Beams, we have two beams to test. Beam number 1, aluminum beams, square shape, bar 12.5 mm multiply 12.5 mm. And beam number 2, stainless steel beam, rod shape, 12.5 mm diameter. Other equipment, Del gauge has to at position Q and P. Each scale 0.01 mm. Weights, we have a 5 unit of weight. Each weight 200 gram. Weight. Steel ruler to measure distance L/2, L/4 and L/4. And W2 load cell, each scale 1/5 Newton. The rest of this lab sheet at page 1 is a calculation. The rest of this lab sheet at page 1, calculation. Page number 2, calculation. Page 3, number 5, procedure, how to run the experiment step by step until finish. And number 6, 7 and 8, results, discussion and conclusion. You do it after a test done. Last page, table for the experiment of deflection of proper cantilever beam. Table number 1 for aluminum beam, 12.5 mm multiply 12.5 mm. And table number 2 for stainless steel beam, 12.5 mm diameter. This is actual equipment of deflection of proper cantilever beam. This equipment consists of Tecumen general beam machine. Beams, we have a beam here, stainless steel beam, diameter 12.5, and then aluminum beam 12.5 multiply 12.5 mm. And then dial gauge, we have two. Weights, 5 unit of weight, each weight 200 gram. steel ruler, okay, and others load cell, this one W2 load cell, and then clamp hook, this one clamp hook, this one clamp block, then this one also clamp block, and then load hanger, this one load hanger. That's all for the equipment. Right now we learn how to read dial gauge and load cell. Okay, dial gauge. This is dial gauge. Dial gauge has two scale, big scale and small scale. In this experiment, our main focus on big scale. On big scale, one scale equal to 0.01 mm. Let's say our needle start from 0. This one needle start from 0. Our needle start from 0, and then it's measuring till 10. Means 10 scale. 10 scale, you are going to multiply 10 scale, multiply 0.01. The actual reading for dial gauge right now 0.1 mm. This one actual reading. 10 scale multiply 0.01 mm equal to 0.1 mm. And now load cell W2. Load cell has knife support, and scale on the spindle. When you rotate this spindle anti-clockwise, okay, knife support will move upward, and if you rotate spindle to clockwise, knife support will move downward. Okay, downward. The purpose of load cell for bring back aluminum beam to the original position in the horizontal position, while at the same time it measure load. Scale on the spindle. Each scale equal to 1/5 Newton. 1/5 Newton. Let's say beam already set to original position before adding weight, and load cell scale start from 30. Okay, horizontal position. After adding weight, we need to adjust beam to original position by rotate the spindle. Okay, let's say we adjust. After we need to rotate the spindle until the beam in the horizontal position, or back to the original position. Let's say this one original position. Right now 34. Scale 34 minus 30. 30 is a starting point, equal to 4 scale. For scale, you need to multiply 1/5 Newton, and then give you actual reading is 0.8 Newton for load cell. From our procedure on the lab sheet at page 3, procedure A, clamp the 12.5 mm multiply 12.5 mm square aluminium beam by using the clamp block as shown on figure 1. Aluminium beam clamp to the clamp block, and then set distance between the clamp block and load cell to be 0.8 meter. This one clamp block, this one load cell. Distance 0.8 meter. Measure by steel ruler, and then let the free end of the beam to be overhang. Okay, before we set distance, we need to place hanger hook, load hanger between clamp block and load cell. Okay, hanger hook. Okay, step B. Move the knife support of the load cell outward or downward until the beam is in the horizontal position. In our equipment right now, we need to move the knife support outward until the beam in the horizontal position. Adjust the load cell. Aluminum beam already set to horizontal position. This one original position before we proceed any test. Okay, scale for load cell right now show 5. We start from 5, scale 5. Okay, and then place the hanger hook at end and dial gauge at P and Q as shown in figure 1. Our equipment position already set based on figure 1. The load cell, dial gauge and hanger hook at end. Hanger hook at end, from clamp block to end, that one for hanger hook, L/2 from load hanger and load hanger N to dial gauge P L/4, dial gauge P to dial gauge Q L/4. Procedure D. Place a load hanger at N and reset the dial gauge reading to 0. Okay, load hanger already set to N, and right now we reset the dial gauge reading to 0. Dial gauge reading already reset to 0, and then procedure E, put a 200 gram weight on the hanger. Okay, 200 gram weight already on the hanger, load hanger, and then F, adjust the load cell until the reading of the dial gauge at Q is returned to 0. Okay, you need to rotate the spindle to adjust the original position, beam in the original position. Load cell reading right now at scale 8. 8 minus starting point is 5. 3 scale. Go to 3 scale. Okay, 3 scale, you need to multiply 1/5 Newton. Okay, I repeat. Right now, load cell show to on the spindle, show scale 8. Scale 8 minus scale 5 means 3 scale. 3 scale, the actual reading you need to multiply 1/5 Newton. 3 multiply of 1/5 Newton equal to 0.6 Newton. And dial gauge P show 5 scale. 5 scale, you need to multiply 0.01 5 scale multiply 0.01 mm equal to 0.5 mm. For dial gauge, 5 right now show 5 scale. 5 scale multiply 0.01 mm. The actual reading for dial gauge P right now 0.05 mm. Okay, 5 scale multiply 0.01 mm equal to 0.05 mm. 0.05 mm actual reading. On lab sheet, write down all data for load cell and dial gauge. We continue to the next step. Next step, H. Okay, or before that G we already record the dial gauge reading, P and the load cell. Okay, right now step number H. Step H. Step H, repeat step E, F and G by adding weight increments of 200 gram until 5 sets of readings are obtained. Okay, we run until 5 units. This is complete weight on the hanger and the final value for the maximum adding of weight. This is adding data for this experiment. After this, we need to remove weight one by one. During remove one by one, we need to adjust load cell to make the beam in the original position before we take any data. One by one we remove. Okay, we are we are done with the test of remove with one by one. As mentioned in procedure I, we already record the reading when the weight are removed one by one. This is the data for the after remove one by one, the complete data for this experiment for aluminum beam of 12.5 multiply 12.5 mm. Okay, is it clear? Okay, final step for this procedure J. Repeat all the above steps for the 12.5 mm diameter stainless steel beam. Okay, yes, same setup for the stainless steel beam. I'm going to show you the data only. The step is same like aluminum beam. Okay, right now, reading for stainless steel beam of 12.5 mm diameter. Okay. Okay, that's all for our test deflection of proper cantilever beam. Thank you very much.